Hello everyone. I am Athar Chauhan. Welcome to our last part of this series where we are discussing internal test 3 of data science. Today we are going to discuss section E of our series. So this section focuses on sequencing and ordering questions. These questions test how well we understand the step-by-step process behind data science workflows. So let's see what this section actually covers. This section contains 7 MCQs and each one asks us to arrange steps in a correct order. The topics range from probability and feature engineering to logistic regression, decision trees, random forest, Spark processing, and SQL workflows. So let's go through each question in a simple and smooth and easy to remember way. So let's come with our first question. Question number 34. Probability steps. So the correct order here is J, K, L, and M. So here's the logic. Sample space J, first define all the possible outcomes, events, then identify specific outcomes of interest, then check that the probability models follows the basic rules, that is probability sum is to 1, L. Conditional probability M. Finally use conditional probability on top of these basics. These orders reflect how probability problems naturally build from basic definitions to more advanced ideas. Let's talk with question number 35 now. The correct order here is JKLM. Here we are going to discuss feature engineering workflow. Option J represents raw measures. Start with raw, untouched data. K represents scaling. Standardize the value so no feature dominates unfairly. Interactions L create new features by combining the existing ones. And dimensionality reduction M reduce the feature count to remove noise and simplify the model. This journey reflects how we transform messy input data into a clean and useful feature. Let's come to our next question. Question 36. Based on logistic regression process. The correct order here is JKLM. J stands for linear fit here. Compute the weighted sum of inputs. Then sigmoid function K. Turn that value into probability between 0 and 1. L. Apply threshold. Compare the probability with a threshold like zero point 0.5. M. Classify. Assign the finite class label. This is how logistic regression makes binary predictions. So our next question now, question 37. Building a decision tree. The correct order here is JKLM. J, root node, start with the entire data set. K, split on feature, pick the best feature that divides the data. L, the child nodes, create branches for the resulting groups. And M, repeat until pure. Keep splitting until leaf nodes are pure or we hit a stopping rule. This is the natural flow of decision tree construction. Question number 38. The power of random forest steps. The correct order here is JKLM. J, bootstrap samples. First, create multiple samples from the training data. Then L, random predictors. At each split, choose a random subset of features. Then K, build trees, construct decision trees on each bootstrap sample. Option M, vote or average. Combine all three outputs by voting or averaging. This is what gives random forest their power. Diversity plus segregation. Now, question 39. Spark processing workflow. Order JKLM. Load RDD. Option J. Load the data into Spark RDD structure. Transformation K. Apply operations like MAC, filter, group by. Actions L. Trigger the execution which actions with actions like count or collect. Then M. The output. Finally store or display the results. Spark separates transformations and actions for efficiency, and this order reflects that. Moving on to our last question of this video, question 40. SQL update command. The correct order here is JKLM. Update J, choose the table. K, set, specify which columns to change and their new values. Where L, select the rows to update, very important to avoid accidental changes. M, commit, save the changes permanently in the database. This is the exact sequence required for safe and correct SQL updates. So let's talk about the key takeaways now. To summarize section E, sequencing is essential for problem solving in data science. Every algorithm or workflow has a logical step by step order. Understanding these sequences ensures correct implementation, fewer errors, and better efficiency. These steps represent real world pipelines used in ML, big data, SQL, and probability analysis. Mastering sequences means you understand not just what to do, but when to do it. So, yeah, thanks for sticking by. This wrap up the section E and completes all the sections of our internal test 3. We are done with our internal test 3.